All right, let's get started. This talk is about event sourcing and how we made it simple at Kickstarter. But let's get started by creating a to-do app together. We first start by generating a brand new Rails app called To-Dos, and then we add a model called Task, just an active record model. And then we start implementing the controller, the index action, the show action, the create action. The first thing I want us to implement together is completing a task. So we create a new action called complete in the task controller. And that action is pretty simple. It finds the task by ID, it updates the completed Boolean attribute to true, and then it just renders the task as JSON. Now, a new requirement comes in, and the new requirement is that we actually want to record the completion date. So when was the task completed? Maybe that's because we want to surface the data to the user. Maybe it's because we want to send an email recap every day of all the things you've accomplished during the day. But let's get that going. So to get that going, we basically just replace that Boolean attribute with a completed add timestamp. It's something that we often do in Ruby on Rails applications. So we just set the completed add timestamps to time.now whenever the task is completed. Now we need to add that column to the model. To do that, we create a Rails migration, and in that migration, we will iterate over every single task that's already completed, and we'll update that completed add timestamp. Now, what should that value be? Should it be the current time? Could it be the epoch time? That data is basically lost, right? We don't know what the completed add timestamp is. So we might just use the updated add timestamp. That's the closest we might have. But still, that's not perfect. Now we want to know who completed a given task. So once again, we go back to the controller, and now we assign the completed by value to the current user. And when it comes to adding that foreign key to our tasks, well, we basically don't know who completed the task beforehand. So once again, that data is lost. Now let's add some event tracking, right? Because as soon as an application goes into production, we need to track some events on it. So we add this snippet of code that's track event with a task completed event, give it a task ID, give it a user ID. And you can imagine how we're adding this in this action, but we actually have that method in almost every single actions in almost every single controller in our app. And now let's add some email notifications. Now that it's a multi-user platform where you can assign tasks to people, etc., you want to get an email whenever someone else completes a task you've created. That's what this snippet of code is all about. And we also want an activity feed. Right? It'd be great if we can have that activity feed so that users can see what has happened on a given project. So for this, in this new line, we create an activity item with a subject that's the task, who is the current user, and the action is completed. Now, when we release that feature of the activity feed, well, we don't have any past activities. So when we release the feature, we start with just a blank slate. And you could write some custom scripts to backfill those activities, but you're just basically guessing, right? So there must be a better way. My name is Philippe Creux. I work for Kickstarter. And today is a special day for Kickstarter because we are turning 10 today. It really feels like it was an Apple keynote and I just went and this is available today. Anyway, Kickstarter is turning 10 today, and over the past 10 years, thanks to Kickstarter helped 162,000 creative projects come to life. 16 million people backed a project on Kickstarter, and we've raised a total of $4.2 billion for those projects. And you can imagine all those creative projects. You might know Kickstarter for the blockbuster projects, like Cards Against Humanity, or Exploding Kittens, or the Pebble Watch, but there are also like thousands and thousands of like small grassroots projects when it comes to like film documentaries, dance projects, art projects, comic books, etc. And so Kickstarter is a great place for that. And I definitely invite you to go on the Kickstarter website today, because to celebrate our 10th anniversary, there are a lot of like Easter eggs and Konami code type of thing on the website, just to make the web weird again. All right, event sourcing made simple. Let's get to it. So what is event sourcing? The idea of event sourcing is that the application state is the result of a sequence of events. Let me illustrate that. We have the application state at the top and events at the bottom. And our user go under our task management application and it creates a new task. When that happens, we create a new event, task created, with a title, prepare sites. We then apply that event to the application state. So we just create a new task with the title prepare sites. Now the user go back to the UI, it clicks on the calendar icon, and it sets a due date to April 20th. We store that event in a database, and then we apply that event to the application state. Wait a second, it wasn't prepare sites, it was prepare slides. So the user go back and updates the title in the UI. That creates a new event, and we then apply that event to the application state. I'm the one preparing my slides, so I assign the task to myself. That creates a new event that's then applied to the application state. I'm kind of late, so let's change the due date to April 24th and apply that to the application state. And finally, as of this morning, my slides are finished. I can mark the task as completed and apply that to the application state. Now in here, we only see events with data, but events can have like a lot of metadata associated to them. You can store when the event was created, who created the event, what device they were using, what IP address that request is coming from. Basically, all the context that you have in your controller at that point in time, you can persist that in the database because you might need it at some point. The good news is that you use event sourcing every day, or you at least use a tool that has some like event sourcing flavor to it every day. You know what that tool could be? Git, yes. When you think about Git, your current working directory is basically the current state of your application. And as you create new commits and as you move between commits, that's how you're creating events. So each event with your commit message might say like why the change happened, what happened, and then the diff is how the change happened. And you get very nice things from Git, right? You can replay those commits, you can branch off, you can go back in time. And that's basically what we're talking about here. It's basically Git for data. Let's go through the key benefits of event sourcing. First of all, as you've seen, you get a full history and a full audit log of the different events that happened. We basically understand how we got there. And that makes debugging a lot easier. When you get events that are coming from different users, or maybe from webhooks and API calls, having like this full history helps you like debug things pretty easily. And it's great for customer support too. When you get a phone call because the data doesn't seem that right, well, you know what happened, at least on the app. And you can get a good sense of how we got there. You can replay events to backfill new attributes. As I said, events have a lot of data and a lot of metadata. So when you add a new attribute to the application state, you can just change the way you change the function that applies that event to the application state, replay all the events, and now your data is in that attribute. You can replay events to recover lost records. Because you have that like full log of events, you can basically just get rid of your application state, destroy it, delete everything, replay all the events, and your application state is back there, which is great when you run a migration. And it just feels, it gives you like a different perspective on your data, the fact that you know that you can just like delete everything and you can always get it back. You can replay events to fix an inconsistent state. Maybe there's been some like race conditions going on, or maybe the way you were applying an event to the state was incorrect. You can just fix that, replay events, and the state is back in a consistent state. And you can obviously travel back in time. If you replay all the events up to like a certain point, then you can look at your application state at that point in time. You basically get a time machine. You can also forward all the events to your data warehouse. Now, events is like a first-class citizen. It's not like you're not creating kind of fake events with this track event method we've seen. It's like the event is the thing, so you can just like forward it to your data warehouse, and they can use that as well, an actual event. And as you add new events to your application, those new events just get forwarded to the data warehouse. You can forward them to your monitoring solution, whatever that is. And you can then have checks and charts, etc., on like high-level application events. For instance, you can check that on Kickstarter, that there is at least one pledge every minute. Even it's way more than that, but at least one every minute. And raise alerts if that doesn't happen. And you can apply events to build tailored projections. So what we've seen is that our events were applied to what I call an aggregate, a task, right? We had the task events applied to the task aggregate. In the same way, you can have your account events applied to an account or to a subscription, etc. Now, there is the main aggregate, the main projection that I call aggregate, but you can have many projections. You can apply those events and transform them to get an activity feed or to get a daily report. You can even like get to something, if you have like an application where you need to have very fast reads, you can build projections that are specific to different needs or specific to different type of users. And as events get created, they just update those projections. And you just have to read from those projections. So in a regular Rails app, you tend to build sometimes some like crazy SQL queries to build some reports. Here you don't need to do that anymore. As the events are created, you can just update that report in place and just read from it. Events can also be used to backfill your data warehouse tables. So I talk about the fact that you can forward those events to your data warehouse, but once you have that in place, if you happen to set that up maybe 6 months or a year in, you can always send all the past events to your data warehouse to backfill all the data. When you release that brand new activity feed feature, well, if you have events, you can also run those events through that activity feed mechanism to get the activity feed from day one. And event sourcing is great for distributed systems. And most of the talks that you can see on event sourcing or most of the literature is around distributed systems. You can have microservices generating events, sending events around, but you don't need a microservice architecture or distributed architecture to take advantage of event sourcing. Event sourcing is actually great for a monolith. So let's talk about event sourcing at Kickstarter and how we tried to make it simple. About 2 years ago, we started a new product called Drip. And Drip is a subscription-based platform to support creators on an ongoing basis. We thought that having a new product was like a very good way to experiment with event sourcing. And here are the requirements of the event sourcing framework we're putting together. It has to be very simple to learn and to use because we had to ship Drip in 6 months. So we didn't have a lot of time to mess around with things and to train people. It had to be very easy to remove. It was just an experiment. So if things went wrong, and because we had that tight deadline, it should be easy to just like remove that whole event sourcing thing and just go back to like regular controllers as we've seen. The solution in the end is just a custom framework that's only like 150 lines of code and relies a lot on active record and active record callbacks. And basically events are regular active record models. And once again, we've only changed the way that we mutate data. We didn't change the way we structure data or the way that we read data from the database. With that in mind, let's build a to-do app together. Let's get back to this action where we complete a task. This time it's a bit different. What we're doing is that instead of mutating the state of the application directly, the task directly, we are creating an event, which is the task completed event. And it's just an active record model. We associate it with the task, and we give it some metadata. Here, we're just giving like the user ID, but we can like fit way more data in there than just the user ID. What the event look like is basically it inherits from the task base event that has all the behavior that you need for that event, and all it has is that apply method. And this apply method is responsible for updating the state, updating the task. So basically, when you create an event that persists the event to the database, and then in an after create call, we simply apply that event to the task, and then we save the task. That's all we do. And that's how the task happened to become completed. If you look at the data we have in the database, that's the task events table. And basically, all events have like an ID that's associated with the task. They have a type that's completed. This event doesn't have any data. And it has metadata, which currently is only the user ID, and a timestamp of like when it was created at. Now, there is a new requirement. We want to record when the task was completed. So we don't change anything in the controller. All we do is we change that apply method in the event. And now, instead of setting the completed attribute to true, we set completed at to the created at timestamp. It's actually very important to set it to the created at timestamp, because if you happen to replay events later on, you want to make sure that you always set the same timestamp. That's why we use created at and not time.now here. When it comes to adding that new column to the database in the migration, all we have to do is to replay events. So that like snippet of 6 lines of code to replay events will be the same everywhere. We basically iterate over every single task. We lock each task to make sure that we don't like have some like concurrency and race conditions in place. And we basically iterate over every single event for that given task, and we apply the event to the task. And then we save the task to the database. And by just doing this, the completed at timestamp is now backfilled. Now we also want to record who completed the task. Same thing. The controller doesn't change. All we are changing is that apply method in the controller. And we basically extract the ID of the user from the metadata that we've been saving from day one. So we just set the completed by ID to the user ID that we've stored in the metadata. When it comes to the migration, to the data migration, we just add the column to the database, and then we replay events the exact same way that we replayed them before. And we now have that completed by ID column set and backfilled. Next step is to create emails, and for that, we need what we call reactors. Reactors are triggered when an event is created, not when it's replayed, and they allow you to perform all the side effects that you need. They can be associated with one or many event types, and they can run synchronously or asynchronously. They used to trigger side effects, and they can also create other events in turn. So let's add an email notification. For that, we will register our register our reactor in what we call a dispatcher. It has a very simple DSL. It allows you to associate a reactor with an event. So here, when a new task completed event is created, we trigger the reactor notify completed. And that reactor is just a lambda. It's just something that that responds to the method call and takes an event as an attribute. So that can be a simple lambda or a proc, or it can be a class if you want to. And so basically here, whenever a task will be completed, that one reactor will be triggered and an email notification will be sent. Let's now add some event tracking. Well, we basically just need to create a new reactor called forward event associated with the task completed. And all it does, given an event, it will merge basically together the data of the event, the metadata, and it will send that to the event bus. And we will just infer the event name from the event class name. And now let's add an activity feed. Once again, just a new reactor. Create activity entry. That reactor just takes an event, and in turn will create an activity entry in the database. Now let's track all the things. There is some inheritance going on. We have a base event at the top level, and then a task-based event, and inherits from that a task completed event. So we can basically tell the dispatcher to dispatch all events to the forward event reactor, and all the task events to the create activity entry reactor. And so as we go and as we create more events, we don't have to do anything for those new events to be forwarded to our event bus. That will just happen. You can also pretty easily decide to run a reactor asynchronously. You just have to switch that keyword argument from trigger to async, and that will queue a job, that active job, sidekick, in our case, will perform. And basically right now on Drip, I think that about 3/4 of our events run asynchronously. So if we go back to like the first example of the task controller, the way it was structured was like the controller was finding a task, updating the task, sending an email, creating an activity feed, and sending events to the event bus, and updating the task, and then reading the result from the database. With our new approach, we create an event that's called task completed, and that event will update the task. And on the side, our reactors will send out emails and forward events and create activities entries. As you can see, all we've changed here is the way that we write data and not the way that we read data. So after 1 year of event sourcing on Drip, I should say 1 year after we launched publicly, in the code, we currently have 15 aggregates, 135 different types of events, 60 reactors, and about like 100,000 aggregate records and 500,000 event records. Not a lot, but enough to get a good sense of like what the aha moments are. So first of all, replaying events is just awesome. It's been just like fantastic to be able to replay events to backfill new attributes we've just added. So for instance, when it's a subscription-based platform, so for instance, when we needed to surface when the subscription was deactivated, well, it was very easy to add this attribute, update the deactivated event to update that attribute, and then replay all the events to get that column in. Replaying events is also fantastic to recover hard destroyed records. When we started working on Drip, we would basically destroy records when a user was destroying something. And at some point, we figured that it was better to soft delete records by just marking them with like a deleted at timestamp. So we just changed the destroyed event to mark the event as, to mark the aggregate as destroyed instead of destroying it, replayed all the events, and the data was back in the database. That's kind of a aha moment. Audit all the things. All our aggregates are audited, and here you can see like a subscription and what we can see in the admin UI. And basically, we can see the whole life cycle of that subscription. From the bottom up, that subscription was like created by the user, then activated, that's a webhook from Stripe, and then everything else is basically webhooks that we get from Stripe. Activated, invoice created, invoice collected. Another invoice the following month was created, but the payment failed, so now it's past due. And Stripe failed to collect that payment 3 times, and now the subscription isn't paid. And that's great to have when you need to debug something for customer support, tracking down race conditions, and we actually had like some of those issues where we were expecting webhooks to have specific data they didn't have, or we were expecting webhooks to be triggered in a specific order, and they weren't for some reason. So it was easy to update our apply method to work with that, replay all the events, and get subscriptions back in the right state. We use a combination of statsd, Grafana, and InfluxDB for monitoring, and we basically send all our events to statsd, meaning that all the events are there and ready to be reported on. So if we need to like explore things, if things go wrong in production, the data is already there, and everything is there for us to create new charts or to report on things. In a similar way, we send all events to our Redshift cluster, and so that we, basically the business analytics team, have like all the events in hand to build reports. And they don't have to like ask us to add new like snippets of code here and there to send new events. They're all there. We actually launched reporting maybe 6 months after we went live, And what was very interesting was that we were able to replay basically all those events and send them all to the Redshift cluster after the fact. So we have all the events from day one in the Redshift cluster. You've noticed that we have nice DSL to basically connect reactors with events. And so because a reactor can create an event, and that event in turn can trigger other reactors that could trigger other events, etc. It's very nice to be able to look at all the events and track down where they are coming from. And so in here, we can see how when you create a subscription, so a subscription created event is created, a reactor will try to activate that subscription. That will issue a subscription activated event that will in turn send a subscription confirmation, a new subscription notification, and add an item in the activity feed. And we have that nice DSL, so we can basically generate those charts programmatically. Well, it actually looks like this when you generate it, so it's not as good looking. But still, it has useful data. And I want to highlight the fact that the data that you write is different from the data that you read, and that's a big thing with event sourcing. You can store as many things as you want in the event, just so that you can, at any point in time, take advantage of this data. We often have this struggle when we work on like a regular database that there is data that's available and we might want to store because it might be useful at some point, but you never know whether it will be or not. While with event sourcing, you can just like store everything in the event and tailor your aggregate for just your current needs. Because you know that as time goes, if you need to surface more data, then you can always add that new column, replay all the events, and get the data back in your aggregate. Now let's talk about the hard parts. Naming is hard, and as you know. And here we are talking about naming immutable events and their attributes. So it's not like code that's soft, and you can refactor and rename things. Here you know that once you've picked a name, that name will last basically forever. So you can spend a lot of time to finding the right name for your events and your attributes. Updating event schemas was surprisingly not a big deal. A lot of people ask me about that and say, hey, you're saying that events are immutable, but over time, you're, I believe, adding like more and more data to it, more and more attributes, new attributes. How do you deal with that? And it turns out that most of the time, new attributes, they have an implicit default value. When you add currency to a subscription, well, the currency was US dollars, basically, for everything, up until the time that you've added currency. So you can basically default to that. If the event data doesn't have the currency, then you know that it's likely to be US dollar. And that goes for most attributes. Most of them would default to, most new attributes on an event would default to the same default value or an empty value. The hardest part and the most complex part, in my opinion, is how you need to destructure a request into multiple events. Because that event sourcing experiment was just an experiment, we didn't want the front end to be aware of that whole event sourcing thing going on. So it's like hidden behind the API. So we provide an API that looks like a regular API. We use GraphQL, but that's irrelevant for this. So this update post mutation takes a title, a description, a published Boolean, a reward ID, and attachment ID. So attachment being like a photo, a document, a video, etc. And so the hardest part is like to basically destructure this into multiple events. To do that, we use commands, and the responsibility of commands is basically to make sure that at a given point in time, you can perform the operation that you're trying to perform. And then it's basically to make a diff between the current state and the new attribute that you get. If you imagine a user that's like updating a post in the UI and you get a full payload with a title, description, published, attribute, etc., well, you need to compare whether like the title has changed. And if it has changed, then you emit an updated title event. You don't want to emit an event every single time the user like updates something if it hasn't changed. And so here you can see how this like one request is dispatch into like 5 commands, and then those 5 commands in turn might or might not generate different events. And that's, in my opinion, one of the most complex parts in our code base. All right, that was event sourcing made simple. So the key things that I want you to remember from this talk is first that event sourcing is the idea that the application state is the result of a sequence of events. Events hold data and metadata that are all the metadata that are available at the time of creation. And we have reactors to trigger side effects. And those reactors can create events in turn. They can't mutate the state. If they need to, they have to create new events in turn. And the key benefits that you get a full history and a full audit log. Backfilling the state of the application is easy. Fixing bugs is way easier thanks to that full history. Also, events are now a first-class citizen, and you can forward them to other services or to an event bus or an analytic platform at no additional cost. Thank you. Yeah, so the question is, what is the framework? Is it open source? Yes. It's a 150 lines of code framework. So we open sourced it. It's not a gem or anything. And I know there are some companies that like take inspiration from it to build their own. There is a link to the blog post, and at the bottom of the blog post, I share a link to this. If you go on Kickstarter GitHub, you can also find it. It will be under a repository called like Rails to-do event sourcing demo or something. Yes?
How do you handle documenting your events so that you keep track of them?
Okay, the question is, how do you document your events so that you can keep track of them? That's a really good question. The events, I didn't show that in the presentation, but the events have like a DSL to define the data attributes that they take. So it's just not a hash that you pass in. You can define all that. And based on this, we actually generate documentation files, like YAML files, I think, that list all the events that we have with their name, with also the name that we send to the event bus, which is a bit different from the actual class name, and a list of all the attributes, and a list of the metadata that you can get as well. And basically, whenever you run the test suite or you boot the app, that configuration file is updated, and so the data team take that as like the source of truth. So the question is, do we capture the whole business logic in the creation of that event when it comes to data validation, etc.? That all happens in the command. So basically, whenever we get an API call or a webhook, that will go through a command, and the command will be responsible for validating attributes. And it will also be responsible for validating that you can issue an event at the current point in time. At some point, we had validations in the events, and we got rid of them because over time, the data changes. And so you can have an event that's like create subscription, and the only attribute it has is an amount. As I said, at some point in time, you might add a currency, and you might want to validate that the currency is like one of the 12 currencies that we support. Well, there are old events that don't have that attribute because it defaults to US dollar. So we ended up like just removing all those validations from those events. It was also to simplify things for engineers so that they would know that validations only go in comments. Okay, the question is like, how do we validate metadata, and especially with this example where we store the user ID as a metadata, and what happens if we delete that user from the database? What we do there is that basically everything is soft destroyed, so we know that the user will never go away from the database. And for Drip, for various reasons, Drip is actually an engine that runs in the Kickstarter monolith. So users are not event sourced, but we know that they will never get hard destroyed anyway. Yeah. Can you migrate from paper trail? That's a very good question. Never thought about it. So the idea of the paper trail gem is that it's basically the opposite. It's not the opposite of event sourcing, but it's basically you update your data, and then paper trail will check the differences and will store those differences in the database. So it's the other way around. And the issue with that is that you can't replay, right, your paper trail if you need to backfill some data. I don't know. It's a very good question.
The opposite order.
Oh, wow. That's intense. Did we get any timing issues with the clock on different servers being different? Meaning that now maybe in the real life, events went ABC, but the timestamp order them is ACB. No. But we have similar things that happen with the way that we process our webhooks, for instance. When Stripe fires webhooks to us, it might fire multiple webhooks at the same time. On their end, they use either Sidekick or delay job to fire them, so they can get in out of order. And then we actually have a separate service that handles them and then report them back to our platform. And so we have 3 or 4 layers of background job type of things. So we end up definitely having events that don't come in the right order. But most of the time, if we have 3 events coming at the same time, they are related to the same kind of event, a subscription is canceled. And we might get 3 different types of events for the invoice, the subscription, and invoice item, for instance. But yeah, we never get into that issue where a user could perform 2 actions pretty quickly, and they would get out of order. That's a very good point. Okay, what kind of locking mechanism we use for events? We use pessimistic locking. So whenever we receive an event, or whenever we create an event, we open a transaction, a SQL transaction, we log the aggregate, we apply the event to the aggregate, and we save the aggregate. So that all goes through pessimistic locking. That's right. If multiple events are created at the exact same time and they have the same timestamp, it might be hard to process them in the right order or replay them in the right order. When we fetch the events for a given aggregate, we sort them by created at timestamp and ID. And that way, we make sure that we will replay them in the same way that they were applied to the aggregate. And once again, from our experience, when we have, it's maybe because we don't have very super strong concurrency going on our aggregates, but most of the time when we get 3 events at a time, it's very likely that one event will update one attribute, another attribute, etc., and they won't really conflict with one another. Okay, the question is, I mentioned that after a year, there was only 500,000 events in the database. And that's because, and it's not a lot, you believe. Okay, Drip, no, it's fine. Drip is still in private beta, and we're actually giving away Drip to XOXO, the festival that's based in Portland. So there is not a lot of traffic on Drip. That being said, this solution might not scale moving forward. We don't know. But based on what I've seen on the Kickstarter code base, where every single email is stored and every single webhooks from SendGrid and Stripe are stored in a database, and the database seems to be keeping up with billions of records, I think that this approach would still scale at Kickstarter level. All right, I think that we're running out of time. Thank you all so much.